Hello, class. This is the Unit 6 review guide. This is the part 1 of it. So the first question I have here is to construct a confidence interval of the population proportion at the given level of confidence. So we want X here to be 520, N to be 1,000, and we have 93% confidence. So to do this, we need to be in StatCrunch. We are going to go to Stat, Proportion Stats, one sample with summary. Number of successes we are going to use is 520. Number of observations of 1,000. And we have a confidence interval at the 93rd percent confidence. And I hit compute. We get a lower limit of about 0.4914 and an upper bound of 0.5486. Let me just write that down very quickly. This gives us a lower bound of 0.4914 and the upper bound of 0.5486. Number 2, we want to compute the critical value z sub alpha over 2 that corresponds to an 87% level of confidence. Alpha here is 13%. So we are doing z sub 0.065, which corresponds to the probability we have a z-score greater than whatever this is equal to 0.065. That picture would look something resembling the following. Have 0 here in the middle. Our value would be down here, where the area above it is 6.5%. So to do that in a StatCrunch, we are no longer on this. We are going to go to Stat, Calculators, and then Normal. We are going to change this to a greater than and put 0.065 to the right of the equal sign. Doing so gives us a value that rounds to be about 1.51. For that particular z-score. The third question, we want to determine the point estimate for the population proportion, the margin of error for the following confidence interval, and the number of individuals in the sample with the specified characteristic. X for the sample size provided. The lower bound of 0.453, upper bound of 0.907, and a sample size of 1,200. So p hat here. We're going to average the two bounds, 0.907 plus 0.453 divided by 2. This would give us exactly 0.68. The margin of error we could find one of two ways, but I'm going to do for this, subtracting these two, 0.907 minus 0.453 divided by 2. This would give us 0.227. And we would get the same thing if you did something like 0.907 minus 0.68. And to get x, we're going to multiply 1,200 times 0.68. That gets 816. That's that particular value. So for number 4 here, a national survey of 2,000 adult citizens of a nation found that 21% dreaded Valentine's Day, The margin of error was 4.6 percentage points with 90% confidence. And we want to explain what this means. So very quickly before doing that, the lower bound for this, when we subtract 21% minus 4.6%, this makes as a decimal 0.164. And the upper bound, when we add those, makes 0.256. So to write this out, let me just type that into here. This is going to be written as there is 90% confidence that the proportion of the adult citizens of the nation that dreaded Valentine's Day is between 0.164 and 0.256, according to this example, of course. Question number 5. I have a researcher wishes to estimate the proportion of adults who have high-speed internet access. What size sample should be obtained if she wishes the estimate to be within 0.02 with 95% confidence if she uses a previous estimate of 0.36. So we're going to go to stat, proportion stats, one sample, with/sample size. So we want this to be 95% confidence. The proportion that we want is 0.36. And the width, we are going to take 0.02 and multiply it by 2, since there's two sides. You get 0.04. And this gives us a sample size of 2,213. Before I write that down, should also make note, part B wants the same thing, but with no prior estimates. So that uses a proportion of 50%, so 0.5. And I'll still put 0.04 here, just to make sure it rounds it correctly. And that will give us a sample size of exactly 2,401. Let me just write those down for us. So the sample size here is 2,213, and here is 2,401 with no prior estimates. Number 6 is how many times does the sample size have to be increased to decrease the margin of error by a factor of 1/7? So we are going to do 7 squared to get ourselves an answer of 49 for that. So whatever's in the denominator, we're going to square it. And there's also a short-ish explanation to go along with that. That is going to be that increasing the sample size by a factor of m results in the margin of error decreasing by a factor of, and whatever we get for this expression, 1 divided by the square root of m, whatever that number so happens to be. So moving along from there, we have question number 7. We want to determine the t-value in each of these cases. So this is the t-value, so the area in the right tail is 0.15. This is with 20 degrees of freedom. So this is t sub 0.15. And our t distribution, we have 0 here. 0.15 would be out there. And we want the area above that. This is the probability that we have a t-score greater than some number is equal to 0.15. Again, with 20 degrees of freedom. So for this, we're going to go to stat. I'm going to go to stat, calculators, and then t. So for this, we are using a degree of freedom of 20. We want the area above to be 0.15. And doing so gives us this t value of 1.064. For that particular value. For the t value, such the area in the right tail is 0.025, this time with 22 degrees of freedom. So the mean is 0 there. 0.025 would be down here-ish. With the area to the, excuse me, this is the right tail. I'm doing the left tail. 1 second. This would be over here, the t-score. The area above it is 0.025 or 2.5%. This is t sub 0.025. Probability t-score greater than whatever is equal to 0.025. And that whatever is going to be, we'll put 0.025 here and change our degree of freedom to 22. That gives us about 2.074. For the t value, since the area on the left now this time is 0.005 with 13 degrees of freedom. So it means 0 is in the middle. This should be down here. With the area below it to the left is 0.005. Probability that we have a t-score less than some number is equal to 0.005. Again, 13 degrees of freedom. This is going to give us 13 degrees of freedom, the area below 0.005. This would give us about negative 3.012 in this case. So negative 3.012. And then for the critical value that corresponds to 98% confidence with 17 degrees of freedom. Here is 0, 98% confidence. We have a positive t-score here, negative t-score here. The area to the left of the negative value and to the right of the positive value must add up to be the remaining 2%. So this is with alpha being 2% or 0.02. This is alpha sub 0.01, since we divide it in half due to the this being a two-tailed test. We could do this one of two ways, but due to the rounding issue with this, I'm going to do it one of the ways, specifically looking at the right-hand side. So this used a degree of freedom of 17. We want the area to the right to be 0.01. This will give us this, which will be positive 2.567, rounding to. And since this is symmetric, it's positive and negative for this. Just to quickly note, the other way we could do this is to use the between option, again with 17 degrees of freedom. And we would put in 1 minus 0.01, which would be 0.99. The only problem though is, as you could see, excuse me, we would use 0.98 due to the 98% confidence. There you go, that's better. The only issue is when we start doing that, the rounding on it may or may not be a little funky. Here is actually not too bad, 2.567 again. But due to the way this rounds, it may be a bit different than what it shows on here. So just be aware when using the between option. But this was positive and negative 2.567. Question number 8. We have a simple random sample of size n is drawn. Sample mean is found to be 17.7. Sample standard deviation S is 4.5. We want to construct a 95% confidence interval about population mean mu if the sample size n is 35. We are going to go to stat. T stats, one sample. This would be a with summary option. The sample mean that we are going to use is 17.7. Sample standard deviation is 4.5. And for this one, we are using a sample size of 35. This was a confidence interval, 95%, and compute. Lower limit, 16.1542. Upper limit, 19.2458. And let me just write that down for us. So lower bound, 16.1542. Upper bound, 19.2458. The same thing though with B here. Same 95% confidence, same mean standard deviation, but now the sample size is 61. So I'm going to make a new one. Stat, T stats, one sample with summary. I'm going to put in the 17.7. Sample standard deviation of 4.5. Sample size now of 61. Again, 95% confidence. And we could see the difference with these two bounds now, right? We could see that the bound shrunk a bit. Lower limit increased to 16.5475, and the upper limit decreased to 18.8525 in this case. So lower limit bound 16.5475, and the upper bound 18.8525. We want to know, how does increasing the sample size affect the margin of error E? Well, that is going to be that this causes the margin of error decreases, which we saw happen, right? Margin of error decreased, so the interval shrunk. Next, we want the 99% confidence interval with that same sample size 35. So this would be, again, stat, summary stats, excuse me, stat, T stats, one sample with summary. Sample mean again of 17.7, sample standard deviation of 4.5, sample size of 35, but now we want our confidence interval to be 0.99. And we could see that this one expanded our interval, made it bigger. 15.6247 for the lower limit, and upper limit to be 19.7753. So lower bound 15.6247, and upper bound 19.7753. So that's it for this part 1 of this Unit 6 review, and I will look forward to seeing you in the second part. Thank you.